This is part 2 of 7.3. The I can statement is I can identify and use angle relationships with parallel lines. So the last time we met, we went over a whole bunch of vocabulary. We're going to use that vocabulary and use those ideas to prove the triangle sum theorem in a little bit more detail than we have before. We've kind of got an intuitive idea of why the angles inside a triangle always add up to 180 degrees. We'll come back to that in just a minute. I do want to go back and look at these vocabulary words and make sure we're clear on how this works. So if we look at this diagram right here, we went through and we had a numeric example where we said, hey, angle 2 is going to be 50 degrees, and then we went and filled out this entire intersection of lines and this entire intersection of lines based on the idea of on one side of a straight line there's 180 degrees and that vertical angles are congruent, and then the fact that these two are parallel made it so that this intersection is exactly like that intersection there. And then we had a bunch of names for the angles in each one of these intersections. So we talked about corresponding angles. Corresponding angles, those are the angles that are in the same place in the intersection. So this is angle 1, it's 130, and this is angle 5, it's 130. They're in exactly the same place in the intersection, so they're ones that are congruent. So remember, congruent is the geometry word for equal. The symbol we use is that equals with the little squiggly on top of it, but corresponding angles are equal. So if I pick this one right here, that 50-degree angle right here, find the one that's in exactly the same spot in the other intersection and it's going to be congruent. We also had other angles that were congruent. Alternate interior, they're on the inside of the two parallel lines, so in here, and they're on alternate sides of the transversal. So if we take this angle right here, angle 4, which is 50 degrees, the alternate interior one for that is on the opposite side of the transversal on the other intersection. So we're talking about these two right here, angle 4 and angle 6, and they're congruent. You can see that they're both 50. The other pair of alternate interior angles on this diagram are angle 3 and angle 5. Both of those are 130. Then we've got alternate exterior. 1 and 7 are alternate exterior. Those two are congruent. 2 and 8, they're both 50. Those two are congruent. And then, of course, we've got vertical angles. We already knew that vertical angles were congruent. So the ones that are directly across from each other, opposite from each other in an intersection. So 2 and 4, those are vertical. 1 and 3, those are vertical. 5 and 7 are vertical. And 6 and 8 are vertical. So all of those are congruent angles. And then we had some other relationships that weren't congruent, but they were supplementary. That means they add up to 180 degrees. So one general name we could use for a lot of these is consecutive. So consecutive means they're right next to each other. So any that are right next to each other in the diagram, they're going to equal 180 degrees. So these are right next to each other. Those are supplementary. They add up to 180. Those are right next to each other. They add up to 180. And even take a look at number 4 and number 5. They're right next to each other in the intersection. So they add up to 180. Now there is a more specific name for that because they're both on the inside and they're on the same side of the transversal. We call those same side interior. So these are same side interior and these are same side interior. And then we've got same side exterior. Same side exterior would be like angle 1 and angle 8, and take a look at those, 130 and 50. They add up to 180 degrees. They're definitely supplementary. So they're either going to be congruent in this list right here, or they're going to be supplementary in this list right here. Again, we don't use consecutive as often as we do these other two, but it is a good thing to keep in mind. So I'm going to come down here and let's talk about this proof of the triangle sum theorem. It'll look a little bit familiar because we did that paper tearing example, or I showed you that quick video there. So I'm going to call this angle A. I'm going to put an A in here, and I'm going to put a C here, and I'm going to put a B here, and then I'm going to draw an auxiliary line. I'm going to add a line to this diagram. So I'm going to extend this line like this. It's going to go right through B. It's going to touch right there. And we're going to mark that these two lines, this line here is parallel to that line right there. Let me make that look a little bit better. Okay, and then I'm going to throw in some other angles in here. I'm going to call this angle E, or let's make that one D. So we're kind of going in order. So we've got A, B, C, D, and we've got E. Okay, so I've actually got 5 angles in the diagram right here, and I'm going to draw some other auxiliary lines. I'm going to extend the bottom of this one and extend the bottom of this one. So you can think of this triangle as kind of being sandwiched in between two parallel lines, the one that goes through AC and the one that goes through B right here. So this blue line at the top is parallel to the black line at the bottom. Okay, now let's take a look at these two guys right here. Let's take a look at angle D and angle B. And to do that, I'm going to ignore everything else in the diagram. So I'm going to ignore that line right there. And think of this as a transversal. These two are on the inside, but they're on opposite sides. So A and D, those are alternate interior angles. So I'm just going to draw some lines to the two of those, and I'm just going to say they're alternate interior angles. We'll just abbreviate totally. Alternate interior angles. Well, if they're alternate interior angles, then that means that they're congruent. Okay, so to mark angles congruent on a diagram, I'm going to put a little arc right here, and I'm going to put a little arc right here. So one arc here and one arc there means that those two angles are congruent. Okay, I'm going to bring back this side, and I'm going to erase this other side for the time being. And we're going to take a look in here. We've got a parallel line here, and this is another one of those transversals. Okay, E and C are on the inside of the parallel line, so these are interior angles, and they're on opposite sides of the transversal, so these also are alternate interior angles. And remember, alternate interior angles are congruent to each other. We proved that up above. So I'm going to put 2 marks in this one and 2 marks in that one. So I'm going to bring this back over here. The reason we wanted to do 2 marks in here is we wanted to make sure that we know that these two we know for sure are equal to each other. They're congruent to each other. And these two are equal to each other. In the diagram, they're congruent to each other. Okay? Now, let's focus our attention on this right here. If I were to draw an arc from here all the way around to here, that equals 180 degrees. Okay, so that's 180 degrees altogether. So if I add D and B and E together, so I'm going to go ahead and write that down. Angle D plus angle B plus angle E equals 180 degrees. Now, if I got really technical, we really should have an M in front there because we're talking about adding the measures together. So the measure of angle D plus the measure of angle B plus the measure of angle E, that adds up to 180 degrees. So we've added those together there. And now I can do something that's pretty clever. Since I know A is exactly the same as D, I'm going to make a little substitution. I'm going to say that now I know that the measure of angle A plus the measure of angle B, so I've added A and B together, and what substitution could we make here? Instead of having angle E, we're going to say the measure of angle C. Those all would add up to 180 degrees. So if I know A and D are the same and E and C are the same, I can make a little substitution right here and then take a look at what I've got. I've got the 3 angles in the triangle. I'll erase this right here. I've got the 3 angles in the triangle adding up to 180 degrees. And again, this is based on several ideas that we've talked about. One, this whole idea of alternate interior angles being congruent, and that on one side of a straight line there's 180 degrees. So if you can think of it this way, when we did this example in class last year, or you watched the video, here's what happened. We took this and we tore this angle off, and we tore this angle off right here, and we put this one up and floated it right in that place right here. Take this one, float it up, put it in that place right there, and that made that nice straight line. Okay, so that's where that proof comes from. That's where the idea of the triangle sum theorem can be proven, and we know that that's a proven fact. We know it's a theorem. We know it's an idea that's been proven to be true. So good thing to keep in mind. You don't have to memorize that proof, but it might not be a bad idea to kind of have this visual picture in mind that we're basically tearing off these triangles right here and then putting them together. So we're going to come over here and we're going to take a look at a couple of problems here. So I've got the worksheet for today up, 7.3b, angle relationships with parallel lines and transversals. It says name each pair of angles as corresponding, alternate interior, alternate exterior, or consecutive. You could also say same side interior, or if it happens to be that they're same side exterior, that would be useful there. So let's take a look at problem number 6 here. On problem number 6, let's notice where they are. This one's on the inside. This is an interior angle, and that's an exterior angle. So definitely not same side interior, same side exterior. Okay, the name for this is going to be corresponding, because they're in exactly the same place in the intersection. So this is kind of in the lower left-hand side of the intersection. That's in the lower left-hand side of the intersection. So these are corresponding angles. And then you just need to remember, is that in the list that are supplementary, they add up to 180 degrees, or is that in the list that's congruent? Well, if they're in exactly the same place in the intersection, it should kind of make sense that they would have to be equal to each other. They've got to be congruent. So I'm going to do 96 equals 8x plus 8. We're going to subtract 8 from both sides. So we're going to get 8x over here. This is an 88. We're going to divide by 8. And we end up with x equals 11. Now, it did just say all we had to do was find x. We don't have to plug it in and figure out what the angles are or anything like that, so that's kind of good. Let's flip over to the back side. This is number 9. It says find x and then find the measure of both angles. So we've got to do both. We've got to find the x and we've got to plug it in and we've got to find both of the angles. Now, you'll notice that it doesn't say you have to name the angles, but it might not be a bad idea to name the angle relationship. So let's take a look at these angles. What name could we give here? Well, you'll notice that they're both on the inside and they're on the same side of the transversal. So we could call these same side interior. I think that's the most descriptive way to describe this. But if you wanted to, you could also say that these are consecutive. They're right next to each other. Consecutive angles, they're right next to each other. Okay, so let's take a look at this right here. That means that, let's see, if they're consecutive, if they are same side interior, that was in the list where they're supplementary. So this angle is going to be a little bit bigger than this angle right here. You can kind of see that looks like it might be obtuse. Not that we go from diagrams, we want to go based on the information, but you can see that that would be the big one and that would be the small one. So that means we're going to add these together and set them equal to 180. So this is going to be 13x plus 6 plus 12x minus 1 equals 180 degrees. Let me make that look like a 1. So when I combine like terms here, I get 25x. This would be plus 5 equals 180. I'm going to move the 5 to the other side, so we get 25. X is equal to 175. And then I divide by 25. Now, luckily this goes in evenly. We get a nice answer for this one. So this is 175 divided by 25, so that's going to be 7. So I've got the x. Now we do need to find both of the angles. So we need to take this and we need to plug it in right here, and we need to plug it in right here. I'm going to change colors just to keep this straight. So this is going to be 13 times 7 plus 6, and the other one is going to be 12 times 7 minus 1. Okay, so let's see, are we pretty good at our 12 and 13 times tables here? Let's check and see. 13 times 7, well, 13 times 10 would be 70, and 7 times 3 would be 21, so this is going to be 91 plus 6, so we get 97 degrees here, so that's one of them. And then this one right here, let's see what we've got. 12 times 7 is 84, minus 1, so that's going to be 83. So the other angle is 83. So this did turn out to be the smaller one. And as a double check, let's make sure when we add these together, do we get 180 degrees? Well, if I took this 3 and shifted it over here, 97 plus 3 would be 100, and this would then be an 80, so this is 180. So we got that one right. Okay, really good skills to practice. There's some logic involved here. There's some equation solving skills. Lots of good stuff here for you to practice. Good luck on the assignment.